Hey there, Aharon Luke again. This is going to be class 3 of 3, where we do a do-yourself fertilizer. I'll quickly go over the first two classes, and then we'll get into like a spreadsheet from Steve Solomon. There's a slide deck. I'm going to wait a bit to see if anybody joins. So let's give it a few minutes. Okay, let's let's start. So this is the third class. We've been discussing nutrient dense food, and nutrient dense food is coming from the organic movement and then into like a soil balancing the cations, the calcium, magnesium. And so this approach to soil fertility and farming produces very nutrient dense food. You're going to have a hard time justifying paying for the fertilizer if you're going for like a big egg and you're just trying to get the most pounds per acre or for amount of money you put into it. So those kind of even in the organic movement, those kind of processes are focusing on potassium and which makes things grow tall, and you're not going to have a nutrient dense result. So let's get started. So the first class started to look at different types of soils. There's a nice soils map that one of the biggest databases in the world at the NRCS with soil survey. And there is a soil pyramid with clay, silt, and sand, and varying degrees of that create the type of soil that you have. And then there's soil profiles, which is the depth and how deep your topsoil is and all of that. And that those things are definitely worth looking at before you start gardening or before you purchase a property, including taking a shovel out there. So the kind of stuff you can do by hand is you can actually determine the type of soil, like sandy loam, clay loam, stuff like that by doing an extrusion test. And so there was in the first class some YouTube videos that go over that. And then there's also like a why I farm, kind of as an intentional spiritual discipline. So like there's a lot of analogies in farming, like things take a while to grow, and then appreciating that as you go through a season allows you to uh, kind of milk it for all it's worth instead of just do it. And so that there's a favorite book I have, Farming as a Spiritual Discipline. Class 2, we went into more of like the Western organic movement, how it was initially appropriated from India. A lot of the green manure, rye vetch, and companion planting, and how they do crop rotation. Those kind of things uh, were appropriated by England, and then they were sold back to India. And so it's kind of a sad story, but within that, American soil agronomists have also taken that tradition, that starting point, and looked into balancing cations and some of the uh, nutrient dense stuff was even like a further development in the 70s with Steve Solomon. And the Rodale Institute there was part of the movement. They were focusing on like just manures and organic matter, but there's a critique by Steve Solomon on focusing solely on local manures and the nutrient deficiencies that can happen. All right, so we started digging into cations and the cation exchange capacity, which are beautiful, important chemistry lessons. So this one is going to be going over soils tests, remineralization worksheets, and actual fertilizer mix. So let's get started. So the first thing maybe, the FTP site has these slides. They're on aslan-how-organics /intern/soil _class_slides. I just have these kind of as HTML kind of FTP type sites. And then the actual fertilizer spreadsheet we're going to be looking at is one step further with this folder, and it's called a DUII_fertilizer. So if you're going to do a soil sample, you really want to go to Logan Labs if you're going to use Steve Solomon, because this lab is paired up with the approach that Steve uses and has all the nutrients that are inputs for his fertility setup. And so I actually have their webpage up here. So when you first get on the page, loganlabs.com, you're here. And what you want to do is go to send a sample. And then they walk you through step one. It's choosing your test. So you're going to want a standard soil analysis report. And then step two is filling out their worksheet. And I think I mentioned this before, but you are going to want to have one sample for each type of soil you have. So if your garden's homogeneous, maybe you just have one sample. You want to go to like 4-5 different locations and get a cut of it, which I'll show you in a second, and then mix that all together, and then get 2 cups and get it in a Ziploc bag. And so that would be one sample for a contiguous type of soil. And you want to be about 6 inches deep. So your samples need to be like a slice of the soil from 6 inches to the top. That's what they call 6 inches. And you just want a standard soils test. And they give you instruction here. There's some other questions on the bottom there. So step 3 is collecting the sample. So this is good. These are good videos. This one here, how to take a soil sample, actually shows you how to get the 6 inches and the slice. So that was a punchline for that. And then basically you just mail it to them, and then you don't send them money, they invoice you once they get it. And then after you pay, they send you the results, usually by email, with your soils results. So back to the deck. And covered most of this stuff. So the remineralization worksheet. So this is getting into Steve Solomon's appendix in his book. The book is great, explains this even more detail than I have, but I wanted to do a quick review of the main concept here of balancing the soil. So, if you're just using the soil as a medium to hold roots and you're going to put liquid fertilizer on there and Roundup and, some kind of pesticide, then you don't really care about how the living soil is doing. But that is different from the organic movement. The organic movement, you're starting to think about like taking care of the health of the soil, and you move away from GMOs and you move away from synthetic fertilizers that shock the soil, that are a lot of them water-based, like I was mentioning. So what we're getting into is this it's called flow calculation. This is the cation balance. So if you are starting to think about nutrient dense food, you want to be able to exchange cations, and to do that, you need to have the soil in a fluffy state. And the fluffy state is when you have the proper balance of calcium to magnesium. Magnesium repels clay, and it has a larger cation. And so, like with a lot of farmers will spread the white stuff in the fall. That is usually like egg lime or something, which is a mixture of calcium and like 38% of its weight is calcium and like 1% is magnesium. And so what you're starting to do is introduce magnesium into the soil. And when you get it in a ratio of, um, I think 69% to 12% calcium to magnesium, you get this effect where the soil just opens up and it becomes fluffy when you walk on it. It's like living. It's really surprising how that works, and I was able to see that happen on the soil that I worked up this year. And if you don't have that balance, then you're going to have something like this where it's not open, it's not flocculated. So there's on the website there is a article. It's this one above here, intro to soil balance underscore big egg. If you click on that, it's a great introduction to how Big Ag is trying to justify locating soil. And it's hard because their price point is based on weight usually. If your teeth fall out from eating vegetables that don't have a lot of nutrients, that's usually called an externality. They're not going to get a feedback on that. And so here's the hero, William Albrecht. So he's the one that pioneered the ratios that are the current theory on balancing cations. So he has 69% calcium and he has 12% magnesium. And those are the biggest players in the soil. So this is a little bit different than pH because a lot of these things might affect the pH, but what he's looking at is a ratio that is optimal for focculating the soil, however you say that. So it's interesting that it's not appreciated more that we can how much the soil has to offer if it's treated intelligently. So here's Albrecht's approach: 69%, 12%. That's a ratio of 5.75. When I put egg lime in the fall, it already has, typically a ratio of 19. So it's kind of like going that direction to opening it up. And the actual egg lime I put on was 38.1. So a little bit less magnesium, but just the idea of like these calcium and magnesium are not water soluble. They don't wash out. They actually cling to the clay particles and adjust the soil. So you can put them on in the fall, and they don't leave the soil throughout the year. Whereas nitrogen would be water soluble, wash out. Let's see. So this is Steve Solomon's acid soil worksheet. I have, my soils were around 5 pH. If and that's pretty typical because the stuff leaches out in the Pacific Northwest. You want to be like 6.6 to 6.5, I think. But if you happen to be basic above 7.0, then you have an excess of cations, and he has a different worksheet for that. So this lesson is just going over the acid soil worksheet. Your TCEC will come off of your soils test, and this is how much nutrients you can push into your soil without it being wasted. So if you got sand, then you got zero. You can't put any fertility into the sand because it'll just wash out. It doesn't hold cations, doesn't exchange them. And pH is relative to the hydrogen. So that's one type of cation. The more hydrogen you have, smaller pH and more acidic is strictly inversely proportional. And then organic matter is another way you can have nitrogen, or you can have it be a part of the cation exchange. So clay and organic matter are going to be able to pass the nutrients you need for your plants. So this is important. It can affect how much nitrogen you need and what kind of TCEC or CEC that you have. So those are what you enter at the beginning. And then I'm kind of juxtaposing it to my spreadsheets. So this is actually what the Logan Labs gives you, something like this. And I just have all the things, the nutrient category written out, the nutrient, the unit, and then this is where I actually enter it off of the soils result. So, first of all are all these header things we just talked about. Then you have anions, that is sulfur and phosphorus. Those things are negatively charged. They have an extra valence electron. These cations are positively charged and they've lost a valence electron. Or I forget, but we'll go back to the original definition just to take the time to do that. So back up here, class 2. Here, getting close. So a cation is positively charged ion. It's an atom, or it's a group of atoms that have more protons than electrons due to having lost one or more electron. Yeah, so they've lost an electron. They have a spot where it can receive one, and they are called cations, which mean going down in valence electrons. Anions are negatively charged because they're going up in valence electrons and have an extra electron, and so they are negatively charged. And then here's the pH is inversely proportional to the hydrogen ion activity. So back down here, we have our spreadsheet, and Logan Labs is organizing the results by these categories, main categories. This is giving you pounds per acre, but then they also repeat some of these as a saturation. This is the actual 69% and 12% here that Albrecht is talking about. So that'll be listed. And then you also have potassium and sodium, which also are exchangeable cations and can affect the soil pH. So if we skip down here to soils test, these over here, these cation saturation, potassium, magnesium, calcium, and sodium affect pH. All of these do. And well, I might be wrong about that. The pH is focused on the activity of the hydrogen, and the cation saturation is where you're trying to balance cations instead of just focusing on how much hydrogen you have or don't have and how that might be filled up with these healthy cations. You're looking at ratios and the pH. So that was in the second class. Forgive me for um, talking this out. So here in this diagram here, you can see that there is hydrogen ions here. So this is excess hydrogen, and it is taking up receptor spots where you could have the other cations. So if you have a low pH, you're acidic, and you have so it's kind of like kind of what we're talking about could be looked at pH, but what you really need to do is you need to be up here like 6.5 pH, and then you also need to have a balance of these cations in addition to really open up your soil. So it's more complex than just pH, and but pH is the inverse of the hydrogen activity. I'm learning this as I go here. All right, so back down to inputting from the Logan labs. So they have base saturation. Now these trace elements these are things that Steve doesn't like the term trace, because if you don't have these, your produce is not going to taste good, and you're going to have deficiencies. So these are important, but you need them in much smaller quantities. And so some of these, they might not like help you with pounds per dollar or pounds per acre, but the human body needs them. So in Steve Solomon's Fertility, you're going to be thinking about these elements and making sure there's enough for the humans and for the nutrient dense, which also is equal to taste. You're going to invest in soil fertility that makes it healthier for your body, which tastes better. All right, so once you've entered in all the stuff from the lab, you're going to have actual levels here. And now Steve Solomon is going to walk you through how you determine your target levels, which are based on all these equations. So, here on the calcium, you have your TCEC or CEC, and you have 400, which is related to, I think, the chemistry of calcium. And then you have your 68% target level from Albrecht. And then, magnesium, you have how much your soil can take, and you have this kind of chemistry equating um, value, and then you have the 12%. So when you get your target value, that'll be the actual amount that you want to put into the soil at a target level. And then the deficit is going to take that target and it's going to subtract what you already have. So then you know what you need to put in for that year. Some of these are like potassium is sensitive because, like I said, if you put too much potassium in, it's just going to grow tall, but you don't have the nutrient dense. So he's restricting that, and he's using this chart down here. So, my CEC was like 12. So he wants me to do 335 pounds of potassium per acre. And my spreadsheet works back to actually the amount that I'm going to be doing, which is more like a quarter acre or an eighth of an acre, or even a 16th of an acre. So, but all these terms are being described in pounds per acre, just to be consistent, or parts per million, which is easily converted to pounds per acre with a soil density factor of like 2. So, yeah, well, with the creation of your own fertility scheme, you also have like warnings, like, yeah, boron can be toxic. So if you get too much boron in there, you're gonna not be able to grow anything. So he's putting a warning here that you don't ever want to exceed 4 pounds per acre in each application per year. And so some of these warnings are for sodium, or for actually calcium. It's actually a minimum. Like you really know that calcium's leaching out. He wants you at least to do 1,500 pounds per acre. And you'll notice that nitrogen is not on here because nitrogen is always leaching out, and you always want 100 to 200 pounds per acre of nitrogen. You can't usually you can't get enough, except for it costs a lot. So there's reasons to make sure you dial into like somewhere into between 100 and 200, and he talks about that in the book. All right, so this is the same thing we just went over. Now, this is the actual spreadsheet. So it's just the Excel format. I just took all of his formulas that he had and just made some conditional statements based on the TCEC, which is synonymous with CEC. And then I also put in like max targets, min targets, and then the deficit, which subtracts out from the actual level that is from the soils test. And what do you think the next spreadsheet is? It is actually making a fertilizer. So to do that, so here's the 3 tabs in the spreadsheet: Logan Labs, the soils, acid soil worksheet, and then this is the creating your own fertilizer. So to do that, you first have to have like a pounds per acre where you're entering in different kinds of inputs and seeing if it's kind of equating what you need in your fertilizer mix. And then I work it down to, I'm not doing a full acre, I'm doing 0.19 of an acre. My rows were long last year and I had 75 feet wide. So I'm getting it down to, I actually needed to purchase 330 pounds of fertilizer. So this is ideal, right? 331. So let's look at the spreadsheet now. So this spreadsheet is on the FTP site. So these results here come from you trying to create your own fertilizer, but in reality, you have to buy them in 50-pound bags or 25-pound bags or whatever from where I buy them from concentrates. So you're going to have to get more than the actual amount you need, but I kind of add that up. So the next thing probably to describe is the composition percent. So, like feather meal is a 1200. So here, this is just a way to show what's in it for what I need. Fish meal is a 9-4.5-0, and it also has sodium. So if I was to get here, if I was to put in let's see, right over here is where I want to put it in. So let's say I want 100 pounds of feather meal. Then this last column is my actual mixture, what I have. So right now, I have 12 pounds of nitrogen from 100 pounds per acre of feather meal. So only 12% of the 100 is nitrogen. So as I'm thinking about what the targets, so here's my targets. So these targets here that come from the targets, the deficit here that I need, this column is just copied over here so I can try to get those values in my fertility scheme. So I already know I need 100 pounds of nitrogen to 200, and so far I only have 12 pounds. And so what this does is it adds up all of your different inputs. Let's say I also needed to do like 100 pounds of fish bone meal. So fish bone meal is a 417.0. So that's going to add in an additional 4 pounds of nitrogen when I mix it all together. And so far I have 16 pounds of nitrogen, but I have a deficit of 84 because I need to get that up to 100 pounds. So what I typically would do would be like, this is going to have to be way more feather meal. And so if you're getting up to like 1,000 pounds per acre, but because I'm only doing, like an eighth of an acre, I need 86 pounds, and that's like 2 bags of feather meal. So over here is starting to think about, oh, they're actually only 40, they're actually 40-pound bags. So I need four bags. Oh yeah, because this is the part I'm going to be putting in the soil, and 50% of it I'm going to be side dressing my nitrogen throughout the year. So it's actually 160, and that's why I needed four. All right. So you would work your way through these. It's kind of an iterative process where you're choosing inputs, and one way to do it is like some of these things like zinc and copper. Copper only comes from copper sulfate um, as a something you can buy from concentrates. So you would need to at least have um, you know whatever input, 7 pounds per acre, and then also like boron comes from borax, just from from the grocery store. So that deficiency, a lot of people do like foliars and work really hard to try to apply this in different ways. But this approach is a mineralization, the cation balance. And so it's going to be looking at like front loading the soil with boron. And boron is in just across the shelf borax. And so maybe you would fill in here like you're going to want like uh, borax is 10% boron. So if I want 2 pounds, I'm going to do something like 25, 20 pounds, So now I'm done with this input, and you can see I drove the difference to zero. And so that's what I'm looking for, is all of these to equal zero, because I'm right along with this deficit. I'm getting the deficits all put in there. So this is the general idea. I was gonna have have somebody fill out the inputs and kind of walk through that, but let's just skip to results. So if you look at A&L, they got this cool graphical soils results. This is not the test you want to do because it has some differences on how they do um, phosphorus, I think, and they also don't show a couple micronutrients that Logan does. So it doesn't really line up with what Steve's doing, but you can see that the organic matter here, the nitrogen, and then these are the macronutrients. You got like your exchangeable cations, and then you got these trace elements, these micronutrients. And then you have your CEC clearly stated. And then they actually do give you a soil fertility recommendation, but this is going to be something more like trying to get the most out of your garden for the least amount of money. They're not going to make a nutrient dense approach. It's not going to be flavor focused. It's going to be get something to grow focus. That's usually what you get from a large ag lab, agricultural lab. So this is the same year, I think. This is 2021, and this is the same recommendation from Logan Labs, and they have aluminum. That's not on Logan Labs, and I think copper, manganese, boron. Yeah, and then they have the phosphorus here. Um, it's using this Malek 3 process, and that is different than how uh, A&L does it. So those are some of the large differences. Steve is using this approach here, and you would get incorrect results using this parts per million here. So in 2019, I figured out the nutrient dense fertility scheme based on pounds per acre deficit. And then I compared that to I got Logan Labs to give me results, and I got the conventional lab to give me results. So you can see that um, the the let's see. So okay, so, like the basic NPK, this is nearly twice the amount of potassium that the conventional lab is offering or asking for. And like on phosphate, this is 195, where this is only 40. So when you're looking at nutrient dense, you're spending more money and you're doing the formulas per like Albrecht and Steve Solomon's research. So that's completely different. And then sulfur. Yeah, look at this. 30 pounds per acre versus 132. And zinc, same thing. Manganese, same thing. These are orders of 2 to 5 times different. And that is a telltale. So um, then I wanted to show you like year over year. So this year in 2019, it was deficient in calcium, but I limed the fields, I think, in 2020. And so you can see I did not need any calcium the subsequent year because I'd already got that covered by liming. So I wasn't going to include anything in my soil fertility mix. So um, that is interesting to note. And hmm, anything else stick out? It's interesting that things keep on leaching out. So I did put quite a bit of these trace elements in, but over the period of a winter, they are needing to be replenished. So um, that is an annual process. And um, let's see. Okay, that's the end. So I'm kind of learning about this. I did um, Solomon's approach past couple years, and my carrots tasted good last year, and they tasted good the year before, and we're getting good produce, good leaf, good greens are coming off the land, and so it feels better than just kind of not knowing what's going on with the soil and just kind of saying, I hope it works out. Like I'm actually monitoring how it's working out and learning about the soil and hopefully appreciating the complexity with all of the other types of farming like permaculture or biodynamic or um, just being able to observe the insect life or tissue health and being able to know like what the problem is just by looking at the leaf. Those are complexities that I can appreciate different methods. But with gardening, you kind of have to choose one fertility method and kind of stick with it. There's a lot of different options, but if you're a mixing it up, then you're gonna get mixed results. So a lot like some of the ideas of like, are you homogeneously fertilizing Are you spreading your fertilizer over a certain area homogeneously so you can just take a sample from the same from random spots the next year, or are you kind of banding it only in one spot so part of your garden is not going to have the same soil consistency? They're like it's better to be consistent if you can. So I think I'm kind of move towards that approach as opposed to just banding it in the row to like spreading the fertilizer across an eighth of an acre at the beginning, and then just side dressing with nitrogen as a supplement for um, once mid-season for light eaters, and maybe like every 6 weeks, 6 weeks. So maybe from transplanting, maybe like a June, July, and then maybe like a like a mid-August or something like that for heavy eaters. So give me a shout if you can. AHAROWN at aslins-how-organics.com.